on lessons 6 and 7 from Unit 10. And the first lesson, lesson 6, is all on factors. So let's review what a factor is before we begin. Remember, a factor is two numbers or two expressions that are, the key words here, separated by multiplication. So separated by multiplication. You can cancel out factors if the same exact factor is on the top as it is on the bottom. It has to be separated by multiplication, though, not addition or subtraction. So a real quick example, if you had A times B over A times C, you can cancel out the two A's because they are attached to the other term by multiplication. So it would be equal to just B over C. But if you had A plus B over A plus C, you cannot cancel out the A's because those are attached with addition, or it could be attached with subtraction. So you cannot cancel out the A's in that example. So let's do our first example. In example 1, you'll notice this is all multiplication on the top and the bottom. So you can simplify or cancel out or reduce common variables or common terms. So the 3 and the 6, you can divide a 3 out of both of those. So you're left with a 1 on top and a 2 on the bottom. The x's, x to the 5th over x to the 8th is x to the negative 3rd, which means it's actually going to be on the bottom as a positive 3. And then y to the 6th over y to the 3rd is y to the positive 3rd. Remember, I've told you in the past that the variable will end up on the side of the fraction wherever the bigger exponent is. So you'll notice 8 is bigger than 5, so that's why x ended up on the bottom. Example 2, you cannot cancel out this x, one of the x's from x squared, with this x down here because x squared is attached to the 9 with subtraction, not multiplication. Same thing here, it's attached with addition, not multiplication. So what you have to do is try to get some factors on the top and or the bottom. And you'll notice on the top, x squared minus 9 is a perfect square. So you can do x plus 3 times x minus 3. Now I have two factors separated by multiplication. Divided by, on the bottom, I can GCF a 2 out of both terms, and I'd be left with x plus 3. Here is your multiplication. So I have two factors on the top. My first factor is x plus 3. My second factor is x minus 3. And I have two factors on the bottom. My first factor is 2. Second factor is x plus 3. Well, you will notice the x plus 3's, there's one on the top and one on the bottom, so they can divide out or cancel out. And on the top, you have x minus 3. On the bottom, you have 2. You cannot reduce the 3 with the 2, even if you could. 3 over 2 doesn't reduce anyway, but if that were like a 6, you cannot divide it by 2 because you can't divide the x by 2 as well. Last example. Again, there is no multiplication because the 2x and the 10 are attached with subtraction. If they were attached with multiplication, then you might be able to reduce. So we're going to try to factor the top and the bottom. So on the top, I can pull out a GCF of 2, and I'm left with x minus 5. So here are my two factors. I got 2 and x minus 5. On the bottom, this is a perfect square. It would be 5 plus x, remember order matters, and 5 minus x. Some of you may be tempted to cross off the x minus 5 with the 5 minus x. That is not the same. If you don't believe me, just plug in a number for x. 10 minus 5 is not the same as 5 minus 10. But what you can do is you can pull out a negative 1 from the 5 minus x, and then it will actually be the same as x minus 5. So I am going to rewrite this with the the 5 minus x. I'm actually going to put it out in the front, and when I pull out a negative 1, just from that term, I'm left with a positive x because it was negative, and then my positive 5 turns into a negative 5. This guy stays the same, now I have two factors that are exactly the same, so they can cancel each other out. And I am left with just 2 on the top and a -1 times a 5 plus x. You can distribute that -1 into the parentheses if you would like. So your final answer, if you distribute that in, would actually be -5 minus x. And if you want to put the x in front, you can also do that as well, but I'm going to leave it like that. So if you get two factors that look really similar, but they're in an opposite order, you just have to divide out a -1, and then hopefully they'll be the same. All right, on to lesson 7. In lesson 7, we're doing factoring as well, but we are adding in another fraction. We're either going to be multiplying or dividing. So you just have to keep in mind that you can cancel out or reduce numbers or variables or factors as long as one is on the top and one is on the bottom. It does not matter if it's on the top right or the left right or the top left or the bottom right or the bottom left. As long as one is on the top and one is on the bottom, you can cancel them out. So you could cancel out something from the top right with the bottom left. That's fine. You just have to make sure that they're not both on the top or both on the bottom. You could multiply across first if you'd rather do that. The only thing is that it might, like in the second example, you're definitely going to want to factor first and then cancel out, because this would be really ugly to try to multiply out. You can do it, but it's just kind of gross. All right, so if in this one, I will show you both ways. So first I will just multiply straight across. So 8 times 10 is 80. There is no other x, so that's x squared, and there is no other y, so that's y to the 7th. On the bottom, 5 times 6 is 30. There is no other x, and there is no other y. Now we can reduce 80 over 30 to reduce with power or multiples of 10. Remember, the zeros just cross off, so you're left with 8/3. And then the x's, remember x to the 5th is bigger than x squared, so it's going to be on the bottom, and 5 minus 2 is 3. 7 is bigger than 3, so it's going to be on the top, and 7 minus 3 is y to the 4th. And that's your final answer. Now what you could have done is you could have reduced before you multiplied straight across. So 5 and 10, you'll notice you can reduce that to 2 over 1. 8 and 6 can reduce to 4 over 3. And then the y's you can also reduce. Y to the 7th divided by y to the 3 is y to the 4th, and then that would be x to the 3rd on the bottom. And if you multiply now straight across, you would get 8 over 3, which is what we got anyway. In the second example, I'm actually going to factor first, because if I tried to multiply straight across, it's going to get really, really ugly. Whenever you have x's involved that are separated by addition or subtraction, you're going to want to try to factor first. So in the first, in the left top, you're going to want to pull out a GCF of 2x, and you're left with x plus 6. So my two factors are 2x and x plus, actually there's 3 factors, because there's 2 times x plus 6. So there's actually 3 factors here. On the bottom, I can pull out a GCF of 4, and I'm left with x plus 2. Over here, this is a 1 a.m. It can factor to be x minus 6 and x plus 2. And on the bottom, it's x plus 6 times x minus 6. All right, so now we can cancel out factors that are the same. You'll notice that there is an x plus 2 on the top right and an x plus 2 on the bottom left, so those can cancel out. You'll notice there's an x plus 6 on the top left and an x plus 6 on the bottom right. And then you will notice that we can reduce 2 with 4, so this becomes a 2. Oh, and there's x minus 6's. So on the top, the only thing we have is x, and on the bottom, the only thing we have is 2. So that is your final answer. Okay, so the last example is actually with division, and if you forgot how to divide with fractions, you're going to copy, change, flip. So we're going to copy the first fraction. You have to do this before you start factoring. You're going to change the division to multiplication, and then you're going to flip the second fraction. Now, if you need to factor, you can, but there's actually nothing to factor because this is all multiplication. So you can either multiply straight across, or you can start reducing first if you would prefer. I'm going to reduce first. So I noticed that the 15 can be divided or reduced with the 5. So that is 3 over 1. The 2 and the 6 can reduce. That would be 1 over 3. And now look at that. I can also reduce the 3 over 3, which actually reduces to 1. So after all of that, I am left with just a 1 over 1, if you want to do that. You don't even need the ones. The x's, there are 2 x's on the top, 8 on the bottom. So that means there will be 6 left on the bottom. There are 7 y's on the top, 5 on the bottom. So that means there will be 2 left on the top. So that is your final answer. You don't need the ones. You can put them there if you would like, but you don't need them. And that is it for this video.